Hello everyone, this is B. Ramat. Today we are going to discuss the next part of the current electricity, that is third part. So in which the concept is the mobility. So now we want to discuss the concept of mobility, the relation between current and drift velocity, the relation between current density, resistivity and conductivity. The last one is the Ohm's law is derived using these concepts. Okay, so first one, mobility. The first one is mobility. Mobility is which is represented by symbol mu, which is defined as the mobility is defined as the magnitude of the drift velocity per unit electric field. So drift velocity divided by unit electric field, that gives the mobility. See, so we know that in the last concept we studied about the concept of drift velocity. Drift velocity is nothing but the average velocity with which free electrons are drifted towards the positive terminal. That is the definition of drift velocity. If Vd is the drift velocity or magnitude of the drift velocity, then electric field applied is equal to E. Then mobility, that is according to definition, that is mobility is equal to ratio of Vd to the E, that is a magnitude of the drift velocity per unit electric field, that gives the definition of mobility. And this is an expression, that is mu is equal to Vd divided by E. The SI unit of mobility is m square divided by Vs, that is nothing but, so the meter square per volt second, that is the SI unit of mobility. Since Vd expression we know that, so that is Vd nothing but drift velocity is equal to minus E capital E tau divided by m, that is the magnitude of the drift velocity. So now we want the only magnitude, so that is the expression for the drift velocity, but now we want only magnitude. Vd is equal to E capital E tau divided by m. This is about the expression for drift velocity. And we have, so mu is equal to E tau divided by m, because so mu is equal to Vd divided by E. In place of Vd you need to substitute this value, hence mu is keep as it is, mu equal to mu. Then in place of Vd you need to substitute this value, hence it becomes E capital E tau divided by m whole divided by E. Then E and E get cancelled, remaining terms mu is equal to E tau divided by m. Sorry, see, this is that expression, mu is equal to E tau divided by m, where tau is the relaxation time. So we already discussed about the relaxation time in last class for an electron, where m is the mass of an electron, E be the charge of the electron. This expression for the mobility is also applicable to all other current carriers like a positive ions, negative ions, holes, like that. And this is about the expression for mobility. Next, we want to discuss the relationship between current and drift velocity. We want to discuss the relation between current and drift velocity. So let us consider a metallic conductor. See, this is a metallic conductor, so you can consider it as a copper metallic conductor. Of its length is taken as capital L, and having the uniform cross section area A. Let n be the number of free electrons per unit volume in the metal. See, n be the number of free electrons per unit volume in the metal. So within the metal, so per unit volume there are n number of free electrons are available. So when the potential difference V is applied across the conductor, see, if we applied a potential difference across the ends of the conductor, then the electric field E is produced inside the conductor. See, for example, if this plate, this end which is acts like a positive plate and this end is acts like a negative plate, or this end is you can consider this is a positive plate and this is the negative plate. So in such a condition, so there is a electric field is developed inside the conductor. That electric field is represented here, so which is equal to E, which is produced inside the metal. Then its expression is equal to E equal to V divided by L. So we studied in the last class, that is the relationship between electric field and potential, in which we studied that this the expression, that is E is equal to produced electric field is equal to so potential per unit volume. See, the potential per unit length, that is you can take it as a relation between electric field and potential. Then the produced electric field is equal to E is equal to V divided by L. Because of the electric field, the free electrons are drifted in the direction opposite to the electric field with the drift velocity Vd. See, so if it is a positive charge and it is a negative charge, electric field is developed inside the metal which is from positive to negative plate. And due to electrons, what happens here, these electrons are drifted towards the positive terminal, or these electrons are so drifted opposite to the electric field. See, electric field in this direction, but electrons are drifting opposite to the electric field, and these electrons are drifted with a velocity Vd. This is the drift velocity Vd. The distance moved by the free electrons in a very short interval of time delta t. See, if the electrons inside the metal conductor, so which are drifted due to potential difference, and so those free electrons are moved by the free electrons in the very short interval of time dt, very within the small interval of time. So the distance moved by the electron is equal to, see, this is that Vd into delta t. So how did you got this expression? Means we know the basic concept, that is a distance is equal to, actually we know the definition of velocity. Velocity is equal to distance covered by time. Okay, then distance is equal to velocity into time. So from this basic concept we can define this one. So as per this, the distance covered by the free electrons due to drift velocity, that is velocity into time. Velocity is, now this is the drift velocity, and time taken is very short interval of time, that is delta t. We considered a delta t. Hence, so that is distance covered by the free electrons in a very short interval of time delta t is equal to, so Vd into delta t. The volume of the conductor, see, the volume of the conductor for this distance is, we know that volume is equal to, so length into area, or area into length. Volume is equal to L into L into L, or length into breadth into height, or you can consider it as area into length or area into distance, like that. So the volume of the conductor for this distance is area into length. So distance we already taken, this is distance into area, again that is equal to volume. Hence volume of the conductor is A Vd into delta t. The number of free electrons drifting in this volume is, see, so within this volume number of free electrons are drifting is equal to, we know that there are n number of free electrons are present within this volume. Hence the number of free electrons are drifting in the within the volume is taken as n A Vd into delta t. N number of free electrons drifting within this volume, A Vd delta t is charge of the each electron is taken minus E. Such n number of free electrons are drifting within this volume. Hence the total charge transferred across the area is, this is in this direction, in the direction opposite to the electric field. The amount of charge transported in the time t across the area of cross section A in the direction of electric field, So from higher potential to lower potential is equal to amount of charge transferred in the time interval t across the area A is equal to, so E be the charge of each electron into n number of this much of charge in the within this volume in a time interval delta t. Hence this is the total charge transferred in the conductor. Then we know that if I be the magnitude of the current in a conductor, then total charge formula is equal to, so the charge is equal to I into delta t. This is from the definition of current. Current is equal to rate of flow of charge. Then Q is equal to I into T. Like this. So we got this expression. Like this, we got this expression, that is Q is equal to delta Q is equal to I into delta T. So from these two equation, from this and this, there is LHS that is equal to delta Q. Hence if LHS equal, obviously RHS also equal. Hence I into delta Q is equal to ENA VD delta T, that is here. Yeah, I into delta Q is delta T is equal to NEA VD delta T. Then so there are some terms cancel here, delta t get cancelled, remaining I is equal to NEA VD. This is the equation, and this equation that gives relationship between current and drift velocity. So this is the relation between current and drift velocity. I is equal to NEA VD. The next concept is expressions for current density, resistivity and conductivity. So in the given diagram, this is the conductor, so this is the conductor of length L of its area of cross section A. There are n number of free electrons are available. So after the application of the potential difference, after application of the potential, these electrons are drifted towards the positive terminal. So the electrons are drifting with velocity Vd. So that Vd we already learned, that is a drift velocity. Since the drift velocity Vd is equal to the magnitude of the drift velocity is E capital E tau divided by m. This is an expression for drift velocity. And one more relation we have, that is a current and drift velocity. So that is equal to I equal to NEA into Vd. Then so this can be written as NEA keep as it is, then Vd, in place of Vd you need to substitute this value. Hence in place of Vd, that is equal to E tau divided by m. And after multiplication it becomes n keep as it is, E into E square, A keep as it is, tau E as it is divided by m. This is the equation number somewhat 3.12. Then the current density definition, we know that in the last concept that current density is defined as, that is current through a unit area. So that is let's see here the definition again they are given. The current density J is equal to the current through a unit area normal to the direction of current, or that is a electric field. So that is the definition of current density that is given here. The current density is equal to current per unit area. Then current equation is here. This is N E square A tau E divided by M. This is here divided by A. See here, according to current density, this is I divided by A. So divided by A means divided by A here, 1A get cancelled, then remaining term J is equal to N E square as it is, A get cancelled, remaining tau capital A divided by M, tau capital E divided by M as it is. This is the expression for current density. This is considered as equation number 3.13. Then from equation number 3.5, so we already learned in the last concept, that is J is equal to, so from the last equation, so that is J is equal to, so relation between current density, conductivity and electric field. So we already learned in the last session, that is J is equal to sigma into E, where sigma is the conductivity. Sigma is conductivity. So the conductivity of the material, hence, so here there are two J equations. One is J is equal to N E square tau A divided by M, and another one is, this is already we learnt in the last session, that is J is equal to sigma into E. So from these two equation, that is sigma E is equal to N E square tau capital A divided by M, or so you can write like this, capital E get cancelled, then sigma is equal to N E square tau divided by M, that is here. Then this is considered as a equation number 3.14. Since the conductivity sigma is a reciprocal of resistivity, so this is also already learnt in the last topic, that is resistivity is equal to reciprocal of conductivity, or conductivity is equal to reciprocal of resistivity. Hence this is given here, since conductivity sigma is reciprocal of the resistivity, hence that is expression is sigma is equal rho is equal to 1 by sigma. Then so you can take like this, so this is 1 by sigma is equal to rho value, the rho value nothing but 1 by sigma, so reciprocal of this value, that gives resistivity. Reciprocal of this value means m divided by n e square into tau. See, this is equation number 3.15. So the current density, resistivity and conductivity. First one is current density. This is an expression for current density. J is equal to N E square tau A divided by M. And this is the conductivity, expression for conductivity. Conductivity is equal to N E square tau divided by M. The next thing is resistivity. Resistivity rho is equal to, that is a reciprocal of this value, that is M divided by N E square tau. So these are the expression for current density, resistivity and conductivity. The next, deduction of Ohm's law using this concept. So now we want to deduce the concept of Ohm's law using drift velocity. See, if we know that basic concept, this one is the basic concept, just we studied. So let us consider a conductor or any metallic wire, in which within the volume there are n number of free electrons are available. So after the application of the potential difference V, then these free electrons are drifted towards the positive terminal. Then so these electrons are drifting with a velocity Vd, that is a drift velocity. See, if V be the potential difference across the conductor of length L, the same concept here, so like this. So the V be the potential difference applied across the ends of the conductor of length L, like this. L having the uniform cross section area A. The magnitude of the electric field inside the conductor A is equal to, we know that the relation between electric field and potential, that is, according to that, the electric field developed inside the conductor is equal to V divided by L. The drift velocity of the free electrons under the action of the electric field E is, we know that the expression for drift velocity, that is a drift velocity within the electric field, that is equal to Vd equal to capital E small e tau divided by m. This is an expression for drift velocity. Then from this equation we can take it as, see, E is equal to V divided by L. Then in place of E you need to write this value of V and V divided by L. So Vd is equal to E keep as it is, tau by m keep as it is. In place of E we can write V divided by L. Then where tau is the relaxation time, we already know that relaxation time nothing but the average time between the two successive collisions. E is the charge of the electron and m be the mass of the electron. The current through the conductor is, we know the definition and expression or relation between current and drift velocity, that is I is equal to NEAVD. Then NEA keep as it is. In place of Vd we need to substitute this value, that is EV tau divided by ML. So in place of Vd we substituted this value, that is EV tau divided by ML. So after multiplication, N keep as it is, E into E becomes E square, A keep as it is, tau into tau divided by ml as it is, so into V. See, this V is wrote here, and this is an expression for current. So the current through the conductor is equal to I equal to NEAVD. So that is equal to this, N E square tau A divided by ml into V. Then so after some adjustments, like V keep as it is, I transfer to RHS side, then it becomes V divided by I, and this term sent to the LHS side, then it becomes ml to the numerator, n e square tau A to the denominator. Then this equation becomes V by I is equal to ml divided by n e square tau into A, and this is considered as R, and a constant for a given conductor at a given temperature. This is a constant for a particular temperature. M, these are the some, there are some constant terms are here. M be the mass of the electron, E be the charge. Then these are the constant terms. Then for a particular conductor at particular temperature, this is an expression, and it is considered as a R. Then V by I is equal to R, that gives the Ohm's law. Or if we transfer this I to RHS side, then it becomes V equal to IR. So that is the expression for Ohm's law. Or you can extend it. If you extend like this, then R is equal to ml divided by n e square tau A. That is the equation is here, ml divided by n e square tau into A. Then so it is considered as L by A keep as it is, L by A as it is. So L by A is keep as it is, remaining m divided by n e square into tau, it is considered as a constant, that is rho, where rho is equal to m divided by n e square into tau. It is called as resistivity. The resistivity of a conductor, which depends on the number of free electrons and relaxation time. Resistivity of a conductor depends on n and tau. The number of free electrons per unit volume is n, depends on the material of a conductor. See, this number of free electrons per unit volume is depend on the material of a conductor, and relaxation time tau depends on temperature. We have rho is equal to R, where L equal to 1 and A equal to 1. If the value of L and A is 1, see, if L is equal to 1 and A is equal to 1, then resistivity is equal to resistance. Therefore, the resistivity definition is like this. The resistivity of a material of a conductor at a given temperature is equals to the resistance of a unit length of a conductor having unit area of cross section. This is the definition of resistivity, and its SI unit is, the SI unit of resistivity is ohm meter. The reciprocal of resistance is equal to conductance, which is represented as a G. Then G is equal to reciprocal of resistance, that is 1 by R. The SI unit of the conductance is Simon or a mho. Reverse of ohm. OHM is ohm, mho, HO is mho. So same symbol also reversed. Then conductivity is a reciprocal of resistivity, hence conductivity is equal to 1 by rho. Then unit of conductivity is Simon per meter or mho per meter. Thank you everyone.